Yes. Let me mark you in. See how you have yours.
No, I haven't turned mine in due to some difficulties.
You know, it was due a couple days ago, right?
Yes.
Did you send me a note saying I had some difficulties?
No, it's because I've been had a family emergency.
All right. So, all right. So I'm hoping that comes in. All right.
Yes.
But most importantly, how's your? Are you all right?
Yes. My parents tested positive for COVID, and we're just quarantined right now. And so my family members are testing positive as well.
So that means you couldn't do your homework, huh?
Well, I was that? Yeah, I was at at home. Just
Watching TV. Was there anything good on TV?
no, I don't watch TV.
Just all right. Okay, I'm gonna make a note here. It's coming. Okay,
Okay, thank you.
and all the best in that situation. I know that's tough. Okay, so now we need to get to the book. Oh, your grades should be posted. Everybody's that I talked to should be there.
Hello, Dr. Whitman. Hope you're
Who's
doing
there?
well today. I'm Lizeth.
Uh, Lizette. Oh, okay, yeah,
Yes.
Lizette. I'm just kidding you.
We stopped on 9.5, page 637.
Let me make a note of that here. 9.5, 637.
Yes.
Okay, so here's my goal for you guys. Let me know if you want to do these. If we can get through 9.5, 9.6, and 9.7, man, we won't have to have class on Wednesday, but it really throws us behind. I may only do Monday. Well, so but that would be my first question. Would you guys want to try to do those three sections tonight?
Yes.
Yeah.
They're very short chapters, too.
Okay,
Yes.
so that's what we'll try to do. If everybody's in agreement, that way you guys can be off Wednesday. If not,
Yes.
and you want to be here?
No, we can do it tonight.
Yeah.
I mean, I want to give you the option. Some classes will pick different things, and most people want to be off the night before Thanksgiving, and um, we just have not had much time to breathe air in this class. But
I need to cook a lot, Dr. Wickman. I have to prep and everything, so that'd be real good for me.
all right, I'm coming over. What page is 9.4 or 9?
Actually, we stopped on 9.5, so we are ahead one, and that's page 637.
6:30. Yeah, that's what we did. There.
Yes.
We anticipated this, and then this at least put it within reach instead of doing 4. Properties of logarithms. Okay, so let's take a look at these. Uh, there are basically 3 properties. And there are actually 5, but 3 of them that you'll use a lot. There's a couple little nuances things. So the product rule in logs, for example, if you have log 3 to the 9th plus log 3 to the 27th, the product rule says you multiply it. But it means also you can break them down in reverse. So if you have log 3 to the 27 plus log 3 to the 9 or vice versa, you do multiply them out, which gives you log 3 to 243. So in essence, you add them. Log 2, again, you add them. Log base, oh, by the way, you have to have the same base. So log base 2 means you have log base 2 P3 times Q. You can see it. If they're addition, they're multiplication. If they're multiplication, they're addition. This is
We're unable to see the book.
real. Thank you for sharing that with me. How about now? Can you see it now?
Yes, yes.
Yes.
Okay, so look, in the key in number 1 is it says it's log base 3, 9 times 27. You can separate that to log base 3, 9 plus log base 3, 27. 2 is an example of the same thing, but in reverse. So you change it to log base 2, and that equals, in the exponent area, P3 times Q. Now the book doesn't show it very well, but P3, the example 2, and the Q are in the exponents. And I know when I first saw this, that makes sense, but they're in the exponents. If you look at the solution on number 2, the P3 looks like it's in the exponent, but Q to the 1 doesn't. So, and there they show the proof. A to the X, A to the Y. A stands for the same basis, and X times Y means X plus Y. Now that's the product rule. The quotient rule is division. They want us to express this log A. They haven't given you the quotient rule. This is the second rule. It's the power rule. The power rule, if you look in the little box, you see the little P up there? The power rule simply means that you can push the P up forward. So the P goes ahead of the whole thing. So if you look at A, -3 comes out front. Boom. Now, in B, they change 4, the square root of 4 over 7. That's this. You have the 4th root of 7, I believe. That's equal to, and 7 technically has a 1. That's then 7 to the 1/4 power. The root is always the denominator. So that's the first thing they're doing in that problem. They're changing that. So you have now log base A to the 1/4, 7 to the 1/4. But now that that's in the exponent of the 7, you can push it up front using the power rule. Another one here to talk about. Log naturel, same as log. It's the exact same thing, almost. Let's take a look at this one. The book shows you, I hit that twice, ln x6. And in the power rule, they push the 6 out front. You have the L and X. Now, technically, there is a 10 here. If there's nothing written, like log 7, it's really a 10. If there's something written, like log, say, 6, 7, then it's not a 10, it's a 6. But if it's blank, nothing there, it's a 10. It's another rule. And I'll make it make sense later on. Okay. So now let's look at C. Well, let's just push it down. The quotient rule. Now, I would have taught product and quotient, but quotient rule means subtraction. But look at the little box. The M is the numerator. That came first. So if you're going to convert these things using the quotient rule, subtraction, the top part, the numerator, is always listed first. We'll see that now. Let's take a look. Uh-oh. So log base t 8 over w. So you're going to take whatever the log is in this case, base t to the 8 minus, you have to repeat it again because it has to be the same log, has to be the same base, log base t to the w. tw. Familiar. I don't know what it means. Number 5, log base, somebody must have wrote that and sent that in. Pretty cool. All right, log base 4 to the 64. Now, it shows subtraction. So you have log base b, 64 comes first, that's the numerator. 16 comes second, but 64 divided by 16 equals 4. It's regular math. Now, express each of the following terms of sums and differences. Well, but what they want you to do is use all the rules that you've had. Now look, it starts out log base a with the numerator of x squared, y5, and z4. That's a quotient. That's the quotient rule. So we take log base a with the numerator minus log base a with the denominator. Now, the second part of this. Line 2. Since you have x squared times y5, that's the product rule. So use plus in between. Log base a x squared, log base a y5. You still have the log a z to the 4. Now, the only thing they do with the log a z to the 4 is the power rule, which pushes the 4 up front. So A is a good learning example. So now they are showed you 3 rules. Now here's a cube. Now, instead of using a cube, they immediately convert that to fractions. And you have 1/3. Then you use the power rule, push the 1/3 out front. But now you still have the division, which means subtraction. It means you have log base a squared b minus log base a c5. Remember, the denominator goes second. Now, what next can you do? Well, look at line 3 a little closer. Let's look at the first part. Log a squared b. That's product rule. So it means we use plus. So then we log a squared. And they skip a step in here. They do 2. It was a squared, but they pushed the 2 out front. So if you look at line 3, they take the 2 using the product rule and push it out front. And then they also use the product rule. Log base a, 2 moved up front, plus log ab. Then they still have the minus log ac5, but then they push the 5 up front using the power rule. So the third last line is what you have. Now, what can you do with that? You can multiply everything. You can take 1/3 times 2. Well, let's see, is there anything else we can do here? Log a to the a. Anything over itself is 1. Just simply have 2. Log ab stays the same, minus 5 ac. I forgot to mention that anything over itself is 1. Of course, you knew that. That's the rule in math forever. Anything over itself is 1. Anything to the 0 power is 1. So they multiply 1/3 times 2, boom, 1/3 times the other log, and then 1/3 times -5, so it becomes easier there. What they do is explained in red, but sometimes not very clearly. C. Right away, we can see we have AY5 over M3 and 4. That's quotient. It means subtraction. We take log B AY5 minus log B M3 M4. So we have subtraction. But we also have multiplication. Log B AY5. Now the other time, they pushed the 5 out front, but not in this one. They, for some reason, they don't follow their own rules. But what they did is this. They showed, like they should have, and I would have done the other one the same way as this. They put log BA, since it's multiplication, it's the addition rule or product rule for addition. Then log BY5. Now, you can see the 5 up in the exponent. It's going to come out front. And you can see that later on. The minus, now, they put a minus sign in parentheses. And again, you have the product rule, which means addition. So you have log BM3 plus log BN4. So anytime you have multiplication, you have addition. Second last line. They simply removed the parenthesis on the right. So the first thing becomes a negative, and the second one becomes a negative. The last line, log BA stays the same. The power rule is used. 5 is pushed up front. Again, the power rule. 3 is pushed up front. And the power rule, the 4 is pushed up front. Express as a single logarithm. Well, you see subtraction right away. You have log 5 log bx. You see the power rule. So the 5 can go x5. That's what they show right away. Look at the solution. First line in the solution. They write the problem first on the left. Then they use the 5 and push it up. The 1/4, they push it up as well using power rule, reverse it. They have subtraction for the same b. So the log base is x to the 5. Since it's the numerator, it goes first. Minus is the quotient rule. Subtraction quotient rule. So you have the y in the denominator. And they simply rewrite the second part. Log b z1/4. Now you have addition, so it becomes the product rule again. The numerator is first. x5 z1/4. Both have the same b, so you multiply the exponents. And y is in the denominator. They simply change z1/4 to the 4th root of z, and I showed you that before. Now, all this stuff about logs is the same thing for log naturel. The only difference between log and log naturel is it's French. So, same rules apply. Log natural 3x plus 1 minus log natural 3x squared minus 5x minus 2. Same basis, subtraction, becomes the quotient rule. Now, what they do next is they factor the denominator, 3x squared minus 5x minus 2. It factors to 3x plus 1 times x minus 2. They cancel the 3x's plus 1. You're left with log natural 1 over x minus 2. And this just takes practice. You see subtraction, quotient, addition, product. Number 9, log A2. Now, this is kind of a weird problem. A lot of students say, well, how do you do this? Well, in order to do this, you're putting in for A approximately 0.301, which is log A2. For, let's see. How do they get that again? 2 times 3 is 6. So they break this down using the product rule. So log A, to the 3.01 plus log base A to the 3, which is 0.477. And then add them. So let's go back to A and make sure everyone understands that one. Don't look at the problem, just look at A. Don't look at the question. Log A says 6. So that could be broken down to log A to the 2 times log A to the 3. So they show that. The log A2 is 3.301, and log A to the 3 is 0.477. They give that to you. Just simply add them, that's how you get it. Is there a question about A? Because if you don't, we gotta make sure you understand that one. We'll do B. B will be kind of like the same. So they start with A to the 2/3 like that. If it's the subtraction rule, log A to the 2 is showing up there in the problem now, is 0.301 minus, because it's subtraction, because it's quotient, log A to 3, but log A to the 3 is 0.477. So you have 0.301 minus that, and you get 0.176. Somebody pick a problem out that we can do. Let's pick one more out to do in this. Anyone. Or any problem.
B.
Would you say which one?
B. On example 9.
Example what? Can you spell it? Bravo, you're saying? Or D, dog?
B. B for boy.
We just did it. We just did B. In log B.
We haven't. E.
So let's look at log B again. B says you have log A to the 2/3, 2/3. This is the quotient rule. So that means you have log A to the 2, and look at log A to the 2 right above it. It's 0.031, boom, for the solution. Minus log A to the 3. And log A to the 3 is 0.477. So you look at the solution, you have 0.301 minus 0.477. You subtract them out, you get 0.176 negative. Let's do C. C is tricky. 3 is to the 4th power. That's how they get log A3. So log A3, if you look up there, log A3 is 0.477. So the solution is log A to 3, the 4th is 0.477, but the power rule moves it out front. So assume you take 4 times 477, you get 1.908. These are fun to do. You have to just study them a little bit, and that's number 9. Number 10, simplify. Look at both of them are A's. You see if they get 8. Anything over itself is 1. Let's see. Log natural e to the negative t. Remember, log natural and e are the same. That's like 1. You simply get negative t. ln and e are the same. Now, C is an example like I shared with you. There's no base, but base is technically 10. 10 over 10 is 1. Using the power rule, the 3k comes up front. Anything over itself is 1, you get 3k. So 10 is the example of the nuances rules, or those little things I said that are just extras. The key is B, noting that ln and e are the same. They are the same thing. So it's like having over 1. go to the next one. This is a long chapter. Simplify each of these following. A, how do you know this? We have the 4 in the front matching the 4 in that, you simply get K, and that's the rule, a base to logarithmic power. As long as you have an A in the front, and the same base, you get X. No matter what it is. B, we already had that. Ln over E is like over 1, boom. C, you add the 10. That gives you the same number in the front as in the back. You simply end up with the exponent, 7t, just like A. Except for they add, instead of a K, they add a T and then a 7 in front of it. The change of base formula. The last thing. This is easy. It looks extremely hard, but I'm going to show you the easy way to do it. What? We didn't explain it. Shoot, they should. Change of base. Well, we'll cover that next one. It'll be easier. So we're going to go to 9.6. Anybody know what page that is?
Yes, that's page 645.
Okay. Thank you. Okay, so let me just do number 1 on another board to get your mind off this methodology here of just going through the book. And maybe this will make it easier too to see. So the book gives you this problem. 2 to the 3x minus 7. This is exponential, equals 32. Now the problem is you have your variable in the exponent, but we can solve that. If we change 32 to a base of 2, I think we get 2 to the, what, 5th power? 2 times 2 is 4 times 8, 16 times 32. Now, since the bases are the same, the rule says then 3x minus 5, 3x minus 7 equals 5. That the two parts in the top will equal each other. And that means you now have 3x equals 12, and then x equals 12. I hope that's easier. Makes sense. Let's take a look again and see what they say. The solution is right, and the solution is 4. They do the same thing. You get 3x minus 7 equals 5. People look on the left. X equals 4. By the way, all of these can be graphed in terms of f of x. And they show it. Remember, y is same as f of x. Now, this is a very important rule. A log has to be greater than 0. It can't be 0. It has to be greater than 0. So now we have a problem here. 3x equals 20. Now the rule is, look at the solution. If you take the log on the left, and you take the log on the right. Now, using the power rule, x then come up front. Now I have log x log 3 equals log 20. Again, let me work this for you a couple ways. make this make sense. The issue with this problem right away is you had an exponent that was your variable. So that's why you use log. You can use ln, by the way, as well. Same thing. Now, this pushes the x up front. Now, to get x by itself, we're going to divide this side by log base, or log 3. It's not a base. Base is 10. They're all the same bases. But if you do that to the left, you do it to the right. These cancel, so x is going to equal that. And let's see what that is. So we have log 20 over log 3. Let's see if we can put that in our calculator. Log, come on. Log. We said 20 divided by log 3. I get 2.726. Let's see if they even give us an answer. They might not even do this. But you might as well see what goes on. Oh, there it is. Log gives you 2.7268, just like we got. Let's go to the next one. Now, these should start to become fun if you understand them a little bit. Example 3. We have a problem with t in the exponent. So look what they do. They divide the left-hand side by 100. It goes away. So they divide the right-hand side by 100. Now you have e to the 0.08t 25. Now instead of taking log, they take log natural. Now log natural and e, the same thing. Just like log, they cancel. Power rule brings it out front. So you have log natural 25 equals 0.08t. Now, to get the answer, we divide both sides by 8, or 0.08. So take log natural, 25, divided by 0.08. Can we put that in our calculator? We're doing the second line in our calculator. Okay, easy. It's good practice. Again, we're going to take log 25 divided by 0.08. $17.47. See if we're right. And it's some very important stuff, because otherwise, if you don't have this class, it's tough. And is that what we got? We take the wrong log. Log natural 25 over 0.0. Do we get 40.2? Let's check. I don't know if you did.
No, we got 17.47.
So I wonder why that would be. So let's take a look. So we took log. Oh, we did take log natural. We got to do log natural. 25 divided by 0.08. And there is the corrected number. 40.235. You have to be careful what you take, because in the application, log and log natural will give you the same result if they're over each other and divided. Well, log natural and Euler will. but not log and log natural. Okay, so let's go back. And then we proved that one. Let's go. I mean, you just gotta follow it. L. You can put that in your calculator. I'm not trying to confuse you. I'm just really just trying to say, be sure to put the right thing in. Now let's look at example 4. They use the power rule. So they put x plus 3 at front. And then on the right-hand side equal sign, they put in negative x up front. Now, how do they get the fourth line there? Well, they take x times log 4. They take 3 times log 4. Because it's a distribution property. You have to look at those as separate numbers. X times log 4 and 3 times log 4. Now, how do they go from that one to the next one? Look at the third, fourth line. You have an x on one side, and you have an x on the other side. But we want to get our x's together. So we put the negative x on the left-hand side becomes positive, and we put the 3 log on the right-hand side, which makes it a negative 3 because you subtract it. So line 5, we have both x's on the left. Now, we can get x by itself by factoring out. So x times log 4 plus log 3. So you're just using distribution property equals negative 3 log 4. To get x by itself, we divide the left by log 4 plus log 3. And we do the same thing to the right. Now, let's do that one too. So we have negative 3 log 4 divided by log 4 plus log 3. So let's put that in our calculator. Again, just to give you practice, to make you feel comfortable, because it's not hard. You just have to make sure you use the right things. So we're going to do negative, not minus. Gotta be careful. Negative 3 log quattro, close parenthesis, divided by, and we're going to use a parenthesis here, log 4, close that parenthesis, plus log 3, close that parenthesis. Now notice we have 2 open parentheses, 3 open parentheses, and only 2 closed. So I have to have another closed parenthesis here. Hit enter. Negative 1.6736. Negative 1.737. They rounded up. Again, just look at the bottom part. I had to keep it all in parentheses. And if you have 2 open parentheses, you have to have 2 closed. If you have 3 open parentheses, you have to have 3 closed. Nothing fancy or unique about that. Now let's look at 5. 5 requires us to use our brain. Now, we're used to having everything in the FOIL system to solve it. Look at the middle term, e to the negative x. They write u equals e to the x. Now, why did they do that? Look at the first part here. If e to the x plus e to the negative x minus 6. Cannot have a negative exponent. It has to cross the line. So it becomes 1 over e to the x. So the second line is changed to have a positive exponent. Now, to get rid of this denominator, That's e to the x. They multiply everything by e to the x. So if you take e to the x times e to the x, you get e to the x squared. That's the third line. But e to the x over ex gives you 1, and negative 6 times ex gives you 0. Now they rewrite this. They don't rewrite it here, but they should. You have e to the 2x plus 1 minus 6 e to the x equals 0. Let me work this for you on the paper and explain to you it. Well, heck. This is using the quad. What they simply do here is look. Nah, I'll show you this part. Because it's goofy. It's not. I'll probably go to goofy. So they give you this. E to the 2x plus 1 minus 6e to the x equals 0. Now what they do is they put this in the order that it's supposed to be. That e to the 2x squared minus 6e to the x plus 1 equals 0. Notice that this is a constant, always goes to the end. This is this. Now, they say u equals e to the x. It's always the middle term. So then you have, then, based on that, u squared. How does that become u squared, Dr.? Well, look. E is not e, it's what? U. E to the x is u, right here. It says so. It's always the middle term. So if e to the x is that, you have u squared. You put e to the x in there, you get e to the 2x. So e to the x is what? U, so you have minus 6u plus 1 equals 0. Now, normally, they would give you an easier one first. That's why I hesitated. This one, you have to use the quad. Negative b plus or minus the square root of b squared, like that, minus 4ac, all this over 2a. So what's your a? What is your b? And what is your c? Anybody. What is a from here?
U squared.
Is 1. The number in front. What is b? Negative 6. What is c? 1. In the quadratic equation, a negative b plus or minus square root of b squared minus 4ac all over 2a comes from x squared minus, let's say, 2x plus 3. A is always the leading coefficient. In this case, it's 1. B is always the second term. In this case, it's negative 2. C is always a constant. In this case, it's 3. Back to the regular schedule program then. Once they do that, so they have u squared minus 6u, they say, they solve it using this. They get u equals 3 plus or minus 2 times square root of that. So e to the x equals that. Now, at the very end, it becomes problematic. You take the log natural of the left to get x by itself. Then you got to take log natural of 3 plus or minus 2 square root of 2. They write it twice, which is goofy. They just should write log natural of 3 plus 2 square roots of 2, and then log natural of 3 minus 2 square roots of 2. Let's just do one. I mean, it's too simple. It looks complicated only because it's something that you don't see every day, but it's not. we're simply going to take this line right here and get the solution. So we'll go to our calculator. We're going to take we'll go down here somewhere. Log natural. Log natural is right here. Boom. We put 3. We're going to put plus 2 square root of 2. Push it out. Close up parenthesis. 1 open parenthesis to 1 close parenthesis. Hit enter. 1.767. Okay, we'll do the negative one. That's right here. We'll just do it that way. We can take log natural. Open parenthesis. 3. This time it says minus. Not negative, minus. 2. Square root. 2. Close parenthesis. Push it out. Enter. Negative 1.7. There it is. Just like the book. And I think a better explanation. I'm hoping. Here's your answer. 1.7, negative 1.76. You'll not see something like that on the test where you have to use the quad for this one, but you'll have to use the quad. Now, easier problems. We have log base 3x to negative 2. This is the change. They didn't see. I don't know how a student could know this. This is a change of base rule. Goodness gracious. Let me show you how simple this is, the book doesn't explain it at all. I don't know why. Let me explain it so you can say, yes, that is an easy. Dr. Thank you for hoping that that's what they'll say. So the book says you have this problem. Log 3 x equals negative 2. This is in log form. We can change this to exponential form. We simply change these two pieces of the puzzle. The base never stays the same. I mean, always stays the same. See, the opposite of what I said. And then you take away the log. So you just write 3, the negative 2 power equals x. All you do is change that. Well, 3 squared is 9. It becomes 1 over 9 because it's negative. I don't know why they give you these hard ones. I would have said 2. So 1/9 is x. Let's take a look. There's 1/9 is x. Changing from log to exponential is the easiest thing in the world. All you got to do is change the two parts around and leave the base to be the same. All right. Look at this problem number 7. You have both logs of the same base. So using the what? Since it's a plus, we use the product rule. They don't even tell you that, I don't think anymore. It becomes x times x plus 3 equals 1. Okay, and what they did is the product rule. Since you have a plus sign, you have log base 10 to the x times x plus 3. equals 1. Let me show you this. I think I just memorized it. Let's see if I can show you this. This is from memorization. Let's see if it works. Log base 10 was it? Yeah. X times x plus 3 equals 1. Now, the change of base rule is this. We switch these two pieces of the puzzle. 10 to the first power equals x times x plus 3. 10 to the first power is 10 equals x squared plus 3x. 0 equals x squared plus 3x minus 10. This factors to x plus 5. Do you have that right? You may have to use a quad here. Was that minus 10? Yeah, it's minus 10. I can't rewrite it. Rewrite it gently again here. 0 equals x squared plus 3x minus 10. That factors to x plus 5 times x minus 2, which means x could be a negative 5 or a 2. Those are solutions. Now, here's the tricky part. This is what x can be. But remember, you cannot have 0 or a negative exponent. If you put negative 5 up in this thing, you'll get negative 5 is not going to work because look, if you put negative 5 right up in here, it becomes a negative 5. A negative 5 and 3 gives you a negative 2. Let's see. Let's see what they say. It might work. Yeah, see, negative 5 gives you a false one because you cannot have a negative log. There it is, negative 5 log. The rules are you cannot have a negative number as a log, and you can't have 0. So immediately when you put up there a negative, it's no bueno. Now on the test, they'll do something like this. They'll say you have log x minus 2 equals something, and you're going to find like x equals let's say 3 or 1, and you're going to say, oh, they're both positive. That's good. It works. No, it doesn't, because if you put 1 up here for x, now you have a log 1 minus 2, it gives you a negative 1. So it doesn't work. So this answer is not the answer. The only answer would be 3. That's how it tests work. If you come to my review, you'll see exactly what I'm talking about. But this is a good key. Now, don't panic, okay, because you say, I understand that, but will I remember? Yes, you will, because I'm going to give you a good review, and you're going to be able to keep your notes. So if you're panicking, don't. I'm not going to let you fall through the cracks at this late stage. Yes, I'm teaching you all this stuff, but you're going to be winners. That's my goal. Let's go to one that you'll see on the test. You can look at this one later. Let's look at this one. This is not that bad. 9. This is subtraction. You know that's the quotient rule. So you have log natural 4x plus 6 over log natural x plus 5. Boom. If you cancel log natural on the right, you can cancel to the left. So I mean, that's the rule of math all the time. You ever do the right, you can do the left. So now you have 4x plus 6 over x plus 5 equals x. Now, I don't like how they show you the solution here. I'll show you my way of how I do it. And you'll do it the same way, Tony. So they give you 4x plus 6 like this over x plus 5 equals x. And technically, x is over 1. And you remember, like in crisscross, 1/2 equals 2/4, means this times this equals this times this. The same thing as here. So you have x times x plus 5, coming from here to here, times 1 times that, which is 4x plus 6. This becomes x squared plus 5x equals 4x plus 6. We want to set it equal to 0, subtract 4 from this side, subtract 4 from that side, so we have plus x. Subtract 6 from this side, subtract 6 from this side, have it equal to 0. We factor that, x minus 2 times x plus 3 equals 0. So this is a 2, this is a negative 3, and we have to check to see if that works. Losing folks left and right. But it's funny stuff. Negative 3 doesn't work. You put it up there, and you can see if you put negative 3 in 3 times 4 is a negative 12 plus 6 gives negative 6. It doesn't work. So you cannot have a negative, so that's good. Now, we got to go now to one last one. Models, growth, and decay compound interest. This is gonna, are you guys still with me? Are you hanging in there?
Yes.
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 We have one more section left.
Yes.
What I would suggest is this. Let's skip to 11.2. We'll do 11.2 because it's easier. And we'll do 9.7 and that one. So Lizette, are you still there? I'm having a hard time hearing. Lizette,
Yes,
you
I'm still
there?
here.
So-
11.2 is page 730.
What we're going to do though is make sure we cover 9.7 on Monday. 11.2 is easy, and that's what you guys need. You need an easy chapter. So let's do that. In fact, I should probably just teach it what the test does. I probably shouldn't even teach all this stuff. I got to be careful I say that, but let me teach you. I should say it this way. Let me teach you the key points. I don't want to kill you guys. Look, and also the book doesn't start out right. I have this book memorized pretty much. It's not my favorite, but let's see. We don't have ellipses. We don't cover ellipses. We only cover circle. We used to, but we don't. Wonder what this is supposed to be circles? It looks like all ellipses. Are we on the circle chapter for sure?
It should be 11.2. Yep, page
Yeah,
730.
7:30.
Circles.
Let's go back to see what the heck this is. Then I'll show you circle and ellipse. Okay. All right. We are going to teach this, and then we'll be done with this. I'll make this as easy as I can. I'm writing this down so I can teach you, I think, the best way, and so you'll feel very good about it, for sure. Okay, here we go. Now, the equation of a circle is given as h k, or the identifying parts of a circle. HK stands for the center. And these are in the ordered pair x, y. So if you have an equation and r, since everybody's leaving, r squared equals 9, r then equals 3. So the equation of a circle then is given as x minus h squared minus y minus k squared equals r squared. Is this a minus? Let me check to see if that's so. I think that's a plus.
Yes, I think it's a plus too.
It's a plus. It's a plus. So look, if you see an equation like this, x minus 3 plus y minus 5 equals 25, the center of the circle is whatever makes this 0. In that case, it's 3. In this case, it is 5. And the radius is square root of that. It's 5. On the test, you'll have one just like something like this. Another version of this one. X plus 2 squared plus x minus 4 squared equals 36. The center of this circle is minus 2, because that makes that 0 and 4. It's an ordered pair. -2, 4. Center. What is the radius? Anyone? Six. Square root of 36. Now, the last problem for the day. They give you this problem. X squared plus y squared minus 16x plus 14y plus 32 equals 0. Now, to solve this problem, you got to complete the squares and set it up so it looks like the form we did before. So we're going to put the x's together. X squared minus 16x. We have to add something to this to complete the square. And we're going to have then plus y squared plus 14y. Let's add something to this to complete the square. Equals, we're going to put 32 on the other side. Is that a minus 32 in the book? Maybe it is positive 32. So that's what we have. We're setting it up so we can have these as squares. Now, to find this number right here, you take half of negative 16 and square it. Half of negative 16 is 8. That gives you 64. So in order to complete the square, you added 64. This becomes x minus 8 squared. It's always half of this one, and then you square it. But if you add 64 to the left, you got to add it to the right. Now, what goes here? Half of 7 squared, what is what? What is that? $49. Add 49 here. So 49 and 64 minus 32 is 49 plus 32. I get 81. Now, if you see this, what is the center of the circle? Anybody? What makes this package 0? Anybody?
It's 8 and -7. And the
Exactly.
radius would be 9.
Amen for the day. That's perfect. I think everybody bailed. Was that you're the only one here?
I'm here.
I'm here too.
I'm just
Yeah, there's
I'm kidding. You're the only one that answered, so I just said that. Okay, so look. Let me see if anybody else came in at the very end that I didn't have that attended. See if they're still here. Giselle, Tamara, are you here? No. Marielle Barrios? No. Who else can I check here? Jose Facundo called in. Say Green, same boat. Miss Moore, are you here? You're always here. Alicia, or no, Miss Moore, is Sabrina not here? Yeah, Miss Moore, you're here. Sabrina? Hello? Okay. I have you, Alicia.
Dr. Wickman, what was, oh, okay, you said we can check in our, it's about our grade, right?
I don't remember that, did I? I said it's on eCampus.
Yeah, okay.
So is Gift here?
Is who there?
It's mentioned.
Gift.
She mentioned that she has an emergency.
She couldn't be here. Okay. Make a note of that. You know, it's a lot of stuff tonight. I'm sorry. I'm trying to give you off for Thanksgiving. How about Daniel Ramos? Right here. Elizabeth Romero. Were you here? I don't have you. Elizabeth, are you here? Not now. No, April. And that's it. Is there anything I'm missing, you all? Brittany, do you have a question or anyone?
So we
So-
won't have class on Wednesday, right?
No, we won't, but we'll have it on Monday. And we'll on Monday we'll cover, as we decided, 9.7 and go to 12.1 and 12.2. It's a lot of stuff then too.
Okay.
Thank you all. Happy Thanksgiving or Turkey Day to you all.
Happy
Same
Thanksgiving
to
to you too.
Be patient.
Good
We're covering a
night.
lot of stuff. Thank you for your patience.
Good night.
No,
Good night.
Good night.